Okay, so in this short video lecture, I'm going to go through 5.2 notes on electron configuration in the periodic table. And basically, I'm going to talk about electrons and their relationship in the sublevels and why the length of each row of the periodic table is the way it is. And then also go through the 4 blocks of the periodic table, S, P, D, and F, which were the shapes of our orbitals when we discussed electron configuration in chapter 4. And then talk a little bit about some special groups and their general properties like the alkali metals, alkaline earth metals, halogens, and the noble gases. So the rows of our periodic table are determined by electron configurations. And so before I jump into that and discuss this table here, whenever we are talking about groups and periods, groups are the columns in the periodic table, and there are 18 groups. And basically what it's saying is that elements that are in a group are arranged together by similar chemical properties. And the reason for that is because they have similar number of electrons in the outermost energy shell. Now, rows, we call them periods, and how long that row is determined by the number of electrons that can occupy that sublevel filled in that period. So when we were writing out 1s, and we always said 1s2, and there's only one, there wasn't a 1p, a 1d, a 1f, whatever, it was just 1s, the maximum number of electrons that it could hold was 2. And so there are 2 elements that are in period 1, hydrogen, helium. And then we would jump down after 1s2 to 2s2 and 2p6. Okay, there isn't a 2d, 2f. So 2s2 plus 2p6, so 2 plus 6 is 8. And so there are 8 elements in the periodic table that belong to period 2. And then period 3 was 3s and 3p. And again, 2 plus 6 is 8. And then we jump down to period 4, and we get 18. Same thing with 5. 6 and 7 increase because now we're throwing in the F's, and that goes up to 32. And I just want to apologize. My children are down here playing, and they're trying their absolute best to be quiet, but small children. Moving on. So here is our periodic table with the 1s2, and then 8 in rows, or I keep saying rows, it should be period 2, period 3, and then we increase that number to 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then, so that would be for the next row as well. And then periods 6 and 7, 6, 7 are 32. Okay, so I guess if I wanted to count that, I could. 1, 2, when we jump down here, there's 14, so that's 16. And then 16 plus 10 is 26, 27, 28, 29, 30, 31, 32. Okay, so now I'm going to talk about S block elements, groups 1 and 2. And so group 1, excluding hydrogen, okay, excluding hydrogen, are alkali metals. And all the alkali metals are silvery in appearance, except for francium here. Soft, super reactive. They will react with air, water, okay, vigorously with water. You can look up sodium and water in YouTube and find some awesome videos. Same with potassium and even rubidium. But yes, they are highly reactive. And the reason for that is because they have 1 electron in its outermost energy shell, and it's easier to just get rid of that 1 than to gain more to fill that energy shell so that they can behave like a noble gas. Group 2 are our alkaline earth metals. So that's beryllium, magnesium, calcium, strontium, barium, and radium. And so these guys tend to be a little bit harder, denser, stronger than our alkalis, not soft. These alkali you can actually cut with a butter knife. That's how soft they are. Whereas over here, not so much. They do react, but it's not as, I don't want to say pretty, but there's like no flames. You just see some bubbles. So they are less reactive than our alkali metals. So that is the alkaline earth metals group 2. Hydrogen and helium, yes, hydrogen's in group 1, and helium, has 2, but it doesn't belong in group 2. Helium is part of the noble gas. So they don't fit with alkali or alkaline earth metals. It's in its own class, and helium is a noble gas. Now, groups 3 through 12, we tend to discuss, or find them, I should say, in our D block. These are our transition metals. All transition metals tend to be very good conductors of heat and electricity, high luster, which means they're shiny like a metal. They're less reactive than our alkaline and alkali metals. So that is our transition metals, iron, cobalt, nickel, copper, zinc, silver, mercury, gold. And these are the new ones that are not on my periodic table, so I've never even, there's seborgium, but yeah. P block elements are groups 13 through 18. So this is my D block, and now these are my P block. So 13 through 18 for the groups. So these guys are considered main group elements. They are the most abundant. They show the trends. They represent the trends very well that we'll dive into here shortly. But group 17 are the halogens, and they are the most reactive nonmetals. Group 1 are the alkali metals. They are the most reactive metals. Halogens are the most reactive nonmetals, and they react with metals to form salts. So that means they will gain an electron from, usually, an alkali metal in a violent explosion, okay, not an explosion, but a violent reaction, and become a stable substance. So that is our halogens. Usually that stable substance is a salt, like sodium chloride, calcium chloride, calcium bromide. Metalloids are semiconducting. They are brittle solids with some properties of metals and some properties of nonmetals. You tend to find them on staircase. So I'll show you that staircase. Your periodic table in the back of your book actually, I think, has it color-coded. And then finally, we have our metals. They're harder, denser than the P block, but softer and less dense than our D block metals. So here's group 17 of the halogens: chlorine, bromine, iodine, just to name a few, but adenine, tennessine, and fluorine belong to the halogens. Here's our metalloids. Okay, this is kind of like a staircase. So boron, silicon, germanium, arsenic, antimony, beryllium, and adenine. So blurry picture of our metalloids there. And finally, our F block, okay, in our periodic table, let me back it up here. F block are made up of two groups, the lanthanides and the actinides. So lanthanides, shiny metals similar to reactivity of alkaline earth metals, and that's really all we know about the lanthanides. And then the actinides, they all seem to be radioactive, and that's kind of the commonality of an actinide. So there's my lanthanides, and there's my actinides. That does it for 5.2 notes. Now there is a worksheet associated with it. It does not look very hard at all. Let me drag it over. It looks something like this, where we have a periodic table and there are letters at the top. So you will identify the element and write the noble gas configuration for these clues. And then on the periodic table given on the first page, which block does A represent, and then identify what each of these letters represent. I give you a nice little word bank. Here it says give the symbol, period, group, and block for the following. So for sulfur, the symbol is S. Okay, so I'd write a capital S. And then the period is the row. So here's sulfur. So it's in 1, 2, 3 period. So 3. It's in period 3. The group is, I'd have to count across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's in group 16. I guess I could have counted backwards because there's only 18. So I did it the hard way. And then the block, this is my P block. So then I'd write P. So you'd have to find those 4 things for all of these. And then it says down here, there are 18 columns in the periodic table. Each has a group number. Give the group numbers that make up. So which ones make up your S blocks? Okay, so if we look back to our notes, let me drag this out of the way. Okay, Groups 1 and 2 are my S blocks, right? Which one makes up your P block? Oh, how convenient, 13 through 18, and so on and so forth. So that is it for 5-2.